All right. Hello, everyone. My name is Daniel. I'm here with Gab. We're both from the class of 2022, so recent graduates, but we're very excited to be here today for the alumni speaker event. The first part of our presentation is like a quick introduction to Git and version control, and then we'll head over to the Q&A section where you can ask us any questions you want about like what it's like being in college as a CS major and what opportunities there are, or even the application process, since I've heard that a lot of you are juniors. So yeah, if we're ready to go, we can get started.
Yep. So
Awesome.
great.
Great. So a quick introduction. My name is Daniel. I'm currently a sophomore at USC, the University of Southern California. I'm studying computer science and business here. And when I was at SI, I was part of the STEM club, CS club, and also the robotics team. So yeah.
I'm Gab. I'm a sophomore at University of Illinois, also studying computer science. I have a minor in econ, and when I was at SI, I was part of the robotics team.
Awesome. And then this slide kind of covers what courses we've taken, what courses our school offers, as well as what the lectures are like and some of the assignments, and then what opportunities are offered on campus. So for USC, here, during my time here, I've taken data structures, algorithms, discrete math, software development, computer systems, and then as part of my business degree, I've taken economics, accounting, and then some general business classes. And the structure for the CS lectures they're very big, like large lecture halls full of like, I think it's about 200 to 300 students each. But every Friday, we have a lab group, which is about 20 students. And that gives you more opportunity to talk to the instructors, the TAs, and get more resources and answer questions. And then the assignments are structured in a way where it's weekly. So it's either once a week or once every 2 weeks. There's a big project that you have to complete. And you're going to have to go to office hours. You're going to have to spend 10 to 20 hours on each project. But it's kind of on your own. There's no like check-in deadlines or anything. It's just the when it's released and when it's due. And yeah, and then for the clubs on campus, there are a bunch. I've listed a few. One of them is called Scope. There's also Hack SC, Troy Labs, Lava Lab. So some of these are CS specific, some of them are CS and combined with a lot of other majors and entrepreneurship. So a lot of great opportunities to meet people, connect with other students. And then campus jobs. So if you're looking for more experience or just want to like a part-time job while you're a student, you can become a course producer, which is kind of like a TA, and just help out with the instructor in teaching the courses. You can also be an office programmer, which so for every office, there's someone that manages the server and just does some tasks that the office wants you to do. So there's that. And then we also do have a career fair. Pretty often where recruiters come on campus and you can hand in your resume and talk about how to apply for the jobs. So yeah, that's for USC.
For University of Illinois, it's similar in a lot of aspects. One thing that's different is a lot of the classes, especially computer science, they're more like theory based. It's a lot more about the math. There's still some coding involved, of course, but they definitely they emphasize a lot on the math part. They even require things like physics, just physics classes for a CS degree. And for projects, some it depends on the class. Some projects are, or some courses have like a weekly project type of thing, like Daniel described. Some courses just do like a little bit of coding each day, something like that. And for the math courses, it also just varies. Um, Usually just like homework sheets like you have in high school. And just like USC, there's a lot of clubs that you can get involved in on campus. Some of the ones I listed there that I'm involved in, just say mobile development, essentially. Project Code is where you can actually do some projects, like real coding projects with other students, which is really cool. And then there's other interest groups like AI and some that I didn't mention there. There's a lot of clubs to get involved in. And if you somehow don't find one you like, you could always make your own, which is really cool. There's research opportunities with different professors and classes that you could be a part of, and career fairs, which you could land an internship through one of those. I have seen a few of my friends do that, which is really cool. And they got like hooked up with an internship for the summer. And if you're like strictly looking to work on a coding project, like a practical project, side projects are sort of the way to go on campus. I know a lot of people that are doing some of them, myself included. You're not really going to find all the practical skills just through classes. I'll tell you that.
Definitely. Awesome. Okay, now we're going to jump into our presentation today. So intro to Git. Git basically is what allows developers to track their changes to their code and then coordinate work on projects with their teams. So with Git, every developer has a local copy of the code base on their own machine, on their own laptops, and they can commit changes to that while also syncing their changes with a central remote repository that has the final version, the final code. And if that sounds confusing, don't worry, we will clear it up throughout this presentation. But for now, just remember that Git basically enables programmers to work independently and then combine their code with a big group. So this is essential for big tech companies with a lot of software engineers who are creating a lot of complex software. Let's just dive right in. So before you learn about Git, you need to learn about version control. And here's an example. So let's say you're working on a group essay project, right? And then every member in your group is responsible for writing a different part of the essay. And let's say you're using Google Docs, but let's say Google Docs doesn't display the live changes that your group members are making, and you can only see the changes that you're making. So your group decides to write your part differently, like separately, and then combine them into one document at the end. But without version control, it can get really messy. You can overwrite someone's code, you can overwrite someone's work, an essay, or you might not know who made the changes and why. But with version control, this is really helpful. So your entire team will have access to the latest version, and your work is also backed up. And then Git, which Gab will cover soon, will also notify you whenever there's a conflict, when you overwrite someone's work by accident, or you're trying to merge your work with them, and there's just a clash, like a conflict. They'll notify you, and then you can solve that manually. And then this just ensures that nothing is accidentally overwritten. But let's get into Git.
So like Daniel mentioned, Git is a version control system. I think it's the most popular version control system. It's used like everywhere, just from personal side projects where you're the only one working on it, to just large companies with hundreds of people potentially working on one project. It's a distributed system, which means different people on their own computers, on their own time, can work on one single project. And the project is hosted on a Git repository, which is some computer that acts as like the source of truth, where all the other projects sort of look to that and make changes to that version in that repository. It kind of works like a time machine. Daniel touched on this, where you can go back to a previous version of your project, which is really nice. And you can go to like previous versions of specific files, and you can look at your version history. And Git uses commits, which is adding a new version. That's how you sort of take a snapshot in the time machine. And branches, where you can branch off, so to speak, and work on some part of your project before merging it into the main branch and making it like an actual feature. And Git is relatively easy to use and learn just through online tutorials that are free, compared to other version control systems that I've seen, at least. So that's definitely a plus.
Definitely. So here's some Git basics. So every developer has a local Git repository that lives on their own computer, as I stated earlier, and they can commit changes. So make a new version and commit that. And here are some of the most common Git commits that you should learn. So Git commit, which saves your changes to the repository. Git push, where you upload from your local computer to the remote central repository. Git pull, which you fetch other people's changes and merge it with your current changes. Git branch, where you split off from the remote repository and create a separate workspace where you can make changes. Git checkout, which is a command that you use to switch between branches, and also git merge, which you can use to combine branches. And it's okay if you're not as familiar with these commands. You'll learn. It's very easy to learn as you start building projects and you start having to use these commands. But these are some of the basic ones.
So when you have a Git repository, a lot of the times you want to host it in a remote location so that other members of the team can work on it. And the best way to do this, especially for like just small side projects that you're working on with a group of friends or something like that, is GitHub, where you can just host a Git repository for free and people can push changes to that without having to work on the same computer, which is really nice. And another nice perk of GitHub is a lot of projects there. If you look for them, you can definitely find some open source projects, which is really cool. Open source project is one where you can contribute and commit changes to, as long as your changes are approved by the person in charge. But it's a place where people like encourage just strangers that they don't know to contribute code to a project. And some of those projects are used by, it's not just like a little side project, it's a project that's used by many people. It could be anything. There's a lot of open source projects out there. And yeah, I mean, GitHub is probably the best way to share a Git repository with other people and have like a nice place to host your projects. It's definitely important for job interviews when they ask for your GitHub link.
All right, and now for some of the best practices that you should do when using Git. So number one, don't include sensitive data. So not all files should be committed. Files containing environment variables like API keys or just sensitive data like passwords or anything like that, that should be omitted. So leave that out when you're committing changes. And then keep your commits focused. Actually, sorry. Yeah, first of all, yeah, don't track large files like videos. Don't track temporary files like logs, and then keep structure commits logically, which means you should keep your commits focused. So making sure that every commit that you make represents one logical change. So don't, like, for example, if you're working on a website and you're fixing the top navigation bar, don't fix the top navigation bar and the rest of the website in the same commit. Like split those up so that if something goes wrong, you can revert that commit and then it doesn't change the whole website. So just, yeah, every commit should be logical. And then write clear commit messages. This is very important when you're working in groups because people need to see what your commit is for. So if you describe, oh, this commit was for fixing the top navigation bar, that's very clear and people can see what changes you make more easily. So yeah, some of the best practices to just work on when you're using Git. And yeah, that's it.
So in summary, Git seems like very daunting, especially with all the commands we showed and just like how complex it can get. But it is a really great tool for version control. Again, I think probably the most popular, definitely the best. And it is industry standard. So eventually you're probably going to run into it. And it's better that you already know it than having to learn it on the job. It's great when you're working with a team. It doesn't really make as much sense when you're working by yourself, but I think that's also the best way to learn it is just by doing it by yourself, just on your own side projects, if you have any. And it does really help you with future projects. It takes away that sort of fear that you're going to lose progress or mess something up or like go down one rabbit hole of changing part of your project before, regretting that and trying to revert it to a previous version. Git helps with all of that. And with the team, the benefits are like tenfold. So it's definitely a great tool, and we do recommend everyone learn it.
And also just a quick thing, the reason we're giving a quick introduction to Git today is because this isn't actually something that you learn in college classes. It's like a lot of classes you're expected to know this before coming into the class. So you're expected to know like very basic Git commands like git add, git commit, git push. So yeah, definitely something worth learning on your own. And yeah, now we'll be moving on to the Q&A sessions for you to ask anything, whether it's Git related or just about our college experience or anything like that.
Awesome. Yeah. Thank you so much for that presentation, Daniel and Gab. I guess I'll start off actually. You were talking about at the end how Git is one of those tools where you don't learn it in your college classes and you're sort of expected to know it. Could you list some of the things that you think that CS majors should know when going into college?
Definitely, yeah. I can start off. So yeah, Git, one of the most important things that you should learn because it's actually how you're going to submit your group projects and personal projects as well. A few other things, I think a lot of the intro courses in college, you're expected to like take AP Computer Science A already. Like like you're expected to know how to code in a certain language before like taking the introduction course. Um, because okay, so AP Computer Science A, I believe, is taught in Java, but a lot of colleges use different languages. I've heard of using C. For USC, we use C++, and then a lot of other schools use Python, like different languages. So once you learn Java, it's very easy to pick up the other languages. So yeah, before coming to college, I would say try to learn Java or Python, and then try to learn Git. And then yeah, Gab, if you want to add on.
Yeah, just to add on to that, I definitely second the you have to know a little bit about a language before jumping into a course. Usually, with most universities, I think you could search up the course and see what language they primarily work in, whether it's like Python, C++. And like Daniel mentioned, if you know Java or really if you know any language, it's not too hard to pick up on the syntax of another language to use it for an intro computer science course. I think like the nuances between different languages only matters like later on. But for those first intro courses, it definitely helps just seeing a few like YouTube tutorials on it, just getting the basics. I'll also add, it's not a requirement, at least none that I've seen, but definitely adding comments to your code just for your own sake and also whoever else is on your team project. Just adding comments to your code for your functions, for your variables, what each segment is supposed to do, all of that definitely helps definitely helps out your project and just keeping a good workflow.
Yeah, that's a great point, actually. Like for the homeworks that you submit, you are graded on what comments you write for at least for USC. So yeah, it's very important to write good comments for your code.
All right, yeah, thank you for that. Another question, was there anything about computer science in college that really surprised you? Like anything that you think someone should consider before deciding to apply as a CS major?
Yeah, I guess I could take this one first. One thing that really surprised me was when I was in high school, I was sort of waiting a little bit until college to like actually learn the practical side of coding and making things like through coding. A lot of people, including just a lot of people I know, like they go into a computer science major not really wanting to learn the computer science aspect. They sort of just want to make things through code, which is totally fine. I mean, I was basically one of those people. But what's surprising is in college, that doesn't really happen. I sort of touched on this before. A lot of the classes are theoretical. Like you walk into a computer science class, it kind of just looks like a math class. They have graphs up there that have, you know, different data structures and stuff, and it's all related to computer science. I mean, computer science is like a theoretical field, but you definitely have to do some work on the side just by yourself if you want to learn the more practical side of coding and making things through code. But the silver lining is, I mean, at least for me, I think it's pretty fun. So you'll never get bored of it.
Awesome, yeah.
Yes, I 100% agree with that. Yeah, the classes are very theoretical. You might expect, like being a computer science major, you're learning how to build websites and stuff. That's only like the only class I've taken that does that is software development. All the other classes are very theoretical, and even though the projects are all code, it's not building website code. It's more so like learning the structure of just a coding language or learning different data structures, like Gab mentioned, graphs, trees, linked lists, all of that. And yeah, you're being tested on those concepts, not like the exams aren't like build out a website. So if you like building out a website is more of a technical skill that you should learn on your own, and it's very useful when applying to jobs. Yeah. Oh yeah.
Which I'll
Also,
just add really quickly before that. Oh, just really quick,
no,
I'll
yeah,
add um, all of that stuff, like all the theoretical stuff, it is important. Like I know there's a distinction between building a website and what you learn in classes, but all the stuff you learn in classes will help you out later on in your career. It definitely is good knowledge to know.
definitely.
Oh, you can.
Oh no, all good. Next question. Yeah.
Okay. What experiences did you have before college that made you decide to study computer science in college?
Great question. Yeah, so for me, I did a hackathon in my sophomore year of high school. It was I think Lancer Hacks. It was part of St. Francis. They just had a bunch of students come to their campus and then build out a project. So if you guys don't know what a hackathon is they set aside a certain amount of time. It's usually like 24 hours, 36. And then within that time frame, you have to build out a project from scratch and then demo it at the end. So through that process, you're gonna learn problem solving, like building out a product, and then working with the team. And I really enjoyed that process of just building something from scratch, using creativity, and yeah, seeing an idea come to life, I guess. But it was a great experience. I just continued doing more hackathons throughout high school and even in college right now. And I think that the possibility of building out something that was just an idea really it was like just excited me. So I continued to explore computer science because of that.
Yeah, for me, similar to Daniel's story, I didn't do any hackathons, but just over time, gradually in high school, I did some computer science, like research and looking into different topics. I started with just like basic web pages because I thought it was kind of fun to just like make something from scratch, like literally a blank page to basically whatever you want. And I kind of just grew from there. I didn't do anything too major. I sort of I was part of the robotics team, trying making their website with a few students. That was kind of cool. But yeah, ultimately, I just became pretty interested and like fascinated by the field in general. And then it just ended up in college. Yeah.
Yeah. We're gonna move on to audience questions now. Yeah, like
Both of you guys have like econ or business as kind of side minors or extra classes. So I'm wondering like what you guys think are the benefits of taking those classes in comparison, or I guess aligned with CS classes.
were you guys able to hear that?
The first part was a little shaky. You might have to repeat it, but
Yeah, he was just asking, both of you guys are taking econ or business related majors alongside your CS majors. What is the benefit of doing that, and sort of why did you guys choose that?
all right. Yeah, great question. So for me, I joined a school club. It was called Hackasy. And through that club, there are different teams. There's like logistics, hacker experience, partnerships, and operations, and then the tech team. I was on the tech team because I came in just being a computer science major, but I got to know a lot of other ma people in the different majors through joining clubs. So we have people from business, we have people studying architecture, economics, design, art, like a variety of majors. And it was just really interesting getting to know them and the classes they were taking. And also so USC offers a dual degree program, which is computer science and business, which is the one I'm in. And I think it was really valuable to, along with technical skills through computer science, also work on practical skills or like soft skills, like communicating with people, effective communication among um, in the workforce, and how to talk to executives, how to pitch a product, stuff like that. You'll learn through business classes. And I was also interested in entrepreneurship because like that the structure of a hackathon is kind of building out a product and then pitching it to the judges. And I really like that structure. So yeah, I got into entrepreneurship and that's why I picked CS and business.
Yeah, I picked a econ minor just because I was interested in the field. I think it's cool, like the theory part of econ, like the game theory and all of that. It's a great way to meet people outside the computer science major. My computer science classes and econ classes don't really mix. They're pretty separate. They're not really like related why I chose computer science and why I chose econ. I mean, I'm just interested in both fields, I guess. I definitely spend most of my time with computer science work, though. I'll tell you that. My econ classes are much easier.
Yeah, makes sense. All right. Any other questions? Yeah, Alex.
So you said you guys are talking about how you do projects, projects. Like what type of things do you have to code for the projects? Like websites or games? What type of projects?
Was the question what type of projects we built?
Yeah, so what sort of projects do you build? I guess for class, but also outside of it?
Yeah, well,
Awesome. Yeah, great question again. For the software development class I took, we had to use everything. So database, front-end language, back-end language, Like we had to connect everything. And for that one, it was a group project, and my group built like a recipe sharing app. It was kind of it's up to your own creativity what you build. But a majority of my projects come from hackathons. So I can pull up a lot of it's on DevPost. So I've been to, yeah, 7 hackathons, and here's some of the projects I've built out. So a couple of them are app development. So this is an iOS app. These two are using React Native, and then also web dev. So yeah, this one just uses I believe React, Node.js, and then Tailwind CSS, which is the styling language. And then yeah, you kind of like these projects are not for class. You kind of just do it on the side. And yeah, I would recommend getting to know the newest languages. There's a new framework called, I think, Vite. It speeds up your development process a lot. So yeah, definitely check out the newer languages and just build out whatever is interesting to you. So like Pulse, I built with my friends. It's like just a fitness challenge app that you can compete with friends on like weekly challenges and then earn points. And then there's like a leadership board. So very simple, very like straightforward. And like before building this, I didn't know much React Native, but I just watched YouTube tutorials and like asked ChatGPT to help and just kind of built it out like that. So yeah, just cool projects like that.
Awesome.
Yeah, and I can't understate the importance of like learning through YouTube. Like Daniel said, that's a really good method. That's how I do most of my stuff. For my own side projects, they're usually just things that I'm looking for a solution for. I remember I was looking at all the bus apps, and none of them were really good. Like they were crashing or slow or just like didn't work sometimes, like for the buses on campus. And so I decided to just like make a little website just for myself. I didn't even share it with anyone. That would just have my own UI and fetch the buses for myself. And now I'm in the process of making that into an app. So hopefully I can just carry it around with me in my phone. I made another side project which just like it was a very like niche thing, which is just stitching like different videos together with like an aspect ratio and things like that. It was for like another project that I was doing, not computer science related, but I decided to make an app that would just like streamline an editing process for me. It's little things like that, like also a restaurant tracker for just restaurants around campus. I was new to the school, so I just wanted to keep a track of like what places I went to, what places were good, what places were bad, what to order, things like that. And I think that's like the best way to do side projects. I don't think it's something you really look for. It's more of just you have a problem and maybe you can make a solution to it.
Awesome. Any others? Awesome then. Yeah. Thanks so much, Gab and Daniel, for the presentation and giving you guys this time for the Q&A.
Thank you so
Yeah,
much.
thank you
course.
guys.
Thank you for
Thanks for
having me.
having us.